and how we're really not going to use it very much, but see how it looks, because we're going to use the fundamental counting principle even more. And here's an example to start us off, okay? Chico has 7 songs on his iPod. He has yet to determine that you can download a whole lot more than that. But 7 is quite a few for Chico. And he has time to listen to 3 songs on his way to school. So he wants to make as many different playlists as possible with 3 songs in different orders. How many ways can this be done? Well, the number of arrangements of 3 songs, as a fundamental counting principle, this is what you would do if you were solving this. He has 3 decisions to make, right? What's going to be the first song? What's going to be the second song? What's going to be the third song? How many choices does he have for his first song? 7. And then 6 because he's used up 1, and then 5. So in this case, it's just 7 times 6 times 5, and you'd find out your answer. Okay? Now, this 7 times 6 times 5, 210 ways. 7 times 6 times 5 could be written this way, right? Because the 4 times 3 times 2 times 1 and the 4 times 3 times 2 times 1 would cancel out. But in spaces where you always reduce by 1, this could always happen. So we could say that it's equal to 7 factorial over 4 factorial. And the 4 factorials on the bottom is the same as 7 minus 3. 3 is important because 3 was the number of spaces that we had. And so we get introduced to this notation, that the number of permutations of n distinct objects taken r at a time. For Chico, he had 7 distinct songs, and he was making playlists of 3, looks like this. And if we would plug this into the formula for Chico, it would be 7, that's not a p, 7p3, which is equal to 7 factorial over 7 minus 3 factorial. And if you expanded these, of course, this is equal to that, and this is equal to this. And so it is a lot more work than just doing the spaces. However, if 4 months later, Chico all of a sudden has 225 songs on his iPad, and he moved 7 miles further away from school. So he now has time on his walk to school to listen to 32 songs. How many songs did I say he had? 252? Something like, I can't remember what I said. So he has 252 songs, and he can listen to 32. And all of a sudden, the fundamental counting principle even is long, right? Because how many spaces would I need to make? 32 of them. And I'd have to write 252 and 251. And so all of a sudden, this becomes 252p32 becomes something that is nicer to write because it's not as big. I don't even know, that might be too big to even put in our calculator, but we can check. If you want to find out where the p button is, permutation button, on your calculator is very close to the factorial button. You can go math over to probability and find out what this would be. So sometimes the permutation formula is nice, especially if you have so many spaces that the fundamental counting principle would be annoying. But most of our questions you're going to find you will tend towards the fundamental counting principle. Okay? This is one of those examples. 8 students are competing in a 200-meter race. How many ways can they finish first, second, and third? Well, there's 3 decisions that need to be made. Who's going to come first? There would be 8 choices. Who's going to come second? 7 people left, and then 6. So you could just multiply this out and get 336. This would also be 8p3. So remember, sometimes it's nice to think of this. That 3 represents, in the fundamental counting principle, the number of spaces you have. And the 8 that's the number you would start with in your spaces. So that connection is nice, but 8p3 is on your formula. Taking it from your formula sheet, that would look like this, and if you simplified that, you would get 8 times 7 times 6. So questions for practice on this one are 4, 6, 7, and 8.